used to provide increasingly creative solutions for a myriad of issues. Okay, it has become essential for every electronics engineer to explore and gain mastery over this subject matter. Various government initiatives like Make in India can become a success if the knowledge that is acquired from books are translated into practical solutions. Okay, so in this regard, we have organized a workshop that provides a hands-on experience on NXP development platform with a built-in ARM Cortex MO Plus processor enabled by Kinetis L series. The speakers for today's session, Mr. Gaurav Singh. He is the CEO of Dalvik Apps. Mr. Gaurav Singh has completed his Bachelor of Engineering in ECE with distinction in 2015 and ME degree from Vidyalankar Institute of Technology in 2017. He is the founder and CEO of WEORG Educational Organization. He is also the CEO at Dalvik Apps, which provides technological solutions to various companies around the world. So I invite and thank Mr. Gaurav Singh for accepting our request and for organizing this, for participating in this workshop. And today's session, we will start with an introductory session by Dr. Swati Jha, Professor, Department of Electronics and Telecommunication, Bharati Vidyapith College of Engineering, Navi Mumbai. And it will be an introductory session on embedded systems. And the later part will be handled by Mr. Gaurav Singh. We encourage the students and participants to actively participate and gain a clear understanding about embedded systems with this workshop. I now request Dr. Swati Jha to take over the session and give an introduction to the embedded systems. Thank you.
Thank you, Dr. Jaivel. It was actually a pleasure hosting this session. It was actually our brainchild because we all understand because of this pandemic, we are not able to meet our students very often. And we also are not able to kind of interact with them the way we did in past. So, but this pandemic should not come out as a deterrent for knowledge sharing. And we used to have a lot of workshops during our normal processes, which the students are not getting these days. So I just thought, let's, join hands and take a step forward so that students are given something beyond their curriculum. And I'm pretty happy to see that in our department, more than 92 students have registered for the course already. And a few of them were also requesting after I closed the response. But, everything comes with a deadline. And those who actually catch the bus, they never miss the opportunity. So I welcome all my students who had faith in me and my team in coming forward and giving us this opportunity to let them go to a next step where we will be able to help them out in making them understand how to make an embedded system project. Personally, I'm extremely thankful to Mr. Gaurav, and here I would also like to name Mr. Amit, who is the MD. Mr. Gaurav is the CEO of Dalvik Apps and WEORG organization, and Mr. Amit Thul is the MD of the same organization. Both of them have a great team, and they have built such a great rapport with Bharati Vidyapith College of Engineering that they never say no to any activity that we look forward and do with our students. Here, I would also like to mention that these people have been instrumental in selecting two very good students from third year presently, and they will be making them work on real-time projects, which is with Mahindra, which is related to battery management and all. So here, I'm extremely thankful. I take this platform to thank Dalvik Apps and BVCOENM organization, who has always stood by us and has always tried to help me and my team organize such events for the betterment of the students, completely free of cost. Well, there's nothing free that comes, but yes, with Dalvik Apps, you can actually see that the efforts that the organizers are taking, it's completely free for Bharati Vidyapeeth College of Engineering. So I'm personally very thankful to Dalvik Apps for letting us organize this in collaboration with them. So today, my role would be to kind of let you go through the basics of microprocessors and microcontrollers, and a little bit about embedded systems. Because what we see is a heterogeneous crowd here. We do not have only the final year or the third year students who have already taken this microprocessor and microcontroller course. We have second year students also who have joined in, and I appreciate their foresightedness, who could see that it will be of some use to them, and why not learn it little early in stage, so that you are well equipped and better suited for making their projects, right? So I appreciate the second year students who have actually enrolled for the course. Third year, it is really, really important, because you people will be the ones who will be deciding your projects now. And with a new knowledge that's being shared in these 3 days, I'm sure you'll be able to sail through. You'll be able to, a new avenue will get opened up, and you can explore the possibilities of making a better embedded system project based on a new platform that you'll be introduced in these 3 days. So with these, I think let's begin with the workshop. So I am presently sharing the screen. I would need a quick feedback if you are able to see the screen. Okay, just let me know if you see the screen. Is it visible, students?
Yes, ma'am.
Okay, wonderful. Yes. Right. So let us kind of go through the topics that we will be covering in next half an hour or so. Why do we call this as a capsule course? I named this as a capsule course because capsule is something which which is giving you every energy instantly, right? So something like that, we thought of a course which will kind of revise things for the third year students quickly, and also give a kind of a platform to the second year students so that they can understand and take on and learn concepts based on microprocessors and microcontrollers, which anyway they will have to do in their as part of the curriculum. So the topics which I will be kind of touching upon today is the background, the definition of microprocessors and microcontrollers, the architectures that we usually use, the various types of processors which are available, and the various generations of processors, how we graduated from 4-bit to say 64-bit today, and what are the criteria for selecting a microprocessor is something which is important, because when you go in market, there is a plethora of microprocessor and microcontrollers that are available. Now, how to choose and what to choose is something that depends on our judicious decision, right? So how do we actually select a microprocessor is a very important question when we go and start making a project. And then coming up to the various applications that your microprocessors and microcontrollers have. So we move to the background. I'm sure you would have heard about the 2-3 more companies which are really wonderful which have been really doing wonderful in semiconductor industry. So Fairchild is one such company which was founded up in 1957, and it was the company that actually invented the first integrated circuit. I'm sure you are aware about an integrated circuit. Integrated circuit is a platform where you are actually merging a lot of components together in a small area, right? So you can actually understand it that way. So integrated circuits, because that was the time when we had everything coming in isolation, everything coming in as a standalone unit, and to make things compact and to pack things in a smaller space was very much required to reduce the size of the items, and hence the concept of integrated circuit was actually a boon to the semiconductor industry, which happened in 1959 with a few of very important scientists who have whose names we have mentioned here: Gordon Moore, Robert Noyce, and Andrew Grove. So these were the three people who were actually behind the scene for making an integrated circuit, the first integrated circuit in the world. In 1968, they had some kind of a conflict and they resigned from Fairchild Semiconductors because they saw that their career was not advancing the way they wanted with Fairchild Semiconductors. So they actually left the company together and formed a new company, which we all know by the name of Intel today. So Intel is the short form for integrated electronics. Most of the electronics engineering graduates do not know the full form of Intel. So that is the reason I specifically wanted you people to know about it. Intel is a short form for integrated electronics, which was formed by three big scientists of that organization. And with their efforts, Intel developed the first microprocessor, which was Intel 4004, and it was developed in 1971. Those who have done the third year course in microprocessors, they know that it was the 4-bit microprocessor which got developed, and we were able to do simple calculations and mathematical stuff using these first microprocessors. So how do you define and what is the definition of a microprocessor? It's nothing but a kind of a processing unit which has peripherals, to which you can attach peripherals, and it can you can give some inputs, whatever input you give based on some kind of algorithm or some kind of processing techniques, it gives you the output. So it's nothing but a kind of a machine that works as per your guidelines. A very simple and simplified machine which works on the guidelines given by the user through programming steps, and it actually performs some action. There are a few things which this microprocessor must have, which includes your registers where you store the data. There should be a bus, that means a connectivity which can take the data from one place to the other place. The control signals, which is provided by the clock, which actually synchronizes every movement. And of course, there is arithmetic and logical unit, which actually performs the logical operations and the arithmetic operations. So these are some of the basic ingredients of a simple machine called microprocessor, which takes inputs, processes it as per your wish, as per your programming details, and gives you the output, desired output in terms of what you require. So, these are some of those important points that we need to know about a microprocessor. It's nothing but a chip which is based on silicon, and it's clock driven. It is register based. That means it has registers or memory that stores data, right? So this is your basic definition of a microprocessor. Coming to the architecture part of it, basically I would want some of you to kind of, from third year, to kind of put it in the chat box, Do we know about the difference between a von Neumann architecture and a Harvard architecture? These are the two prevalent architectures on which the microprocessors and the microcontroller industry is based. So anybody who can tell me what is the basic difference between the two types of architecture? The major difference, anybody, those who have actually done the course, I would request them to come forward and let me know. Yeah. Looking forward for a response from your side, students, specifically third year students. Yeah.
I mean, von Neumann model, we have two types of memories, like the memory is segmented.
Yes. Okay.
And in Harvard architecture, there is no separation. Only one memory is allotted for both the purposes, like data memory and memory for storing.
Wonderful. So very nice. Good, Anshu. As usual, you have, I think in class also, he's one of the most active members and he keeps replying to the queries. For those people who do not know about this, I would just want to explain two things here. You know, when you have memory means internal storage space where you can put in some data. So there are two types of memories that we have. One is program memory, where you write codes and it gets executed. And the other one is the data memory. So whatever is getting executed in the program memory, the data, intermediate data is getting stored in the data memory. So there are two types of memories basically, program memory and data memory. So if you have both of them in a single memory space, then it is one of the architectures. If both of them are separate, it is said to be the other type of architecture. So basically it's based on whether the program and data memory is at one memory location or it is like separate modules and you have to get data from other places. So it's like two different space. I think we'll talk about this in little while from now for better understanding of the second year students, but I just wanted to kind of find out from the third year how much do they remember. So if you see a very simple explanation of a microprocessor is here, an input device where you have a microprocessor which has ALU, control unit and registers, all of it, which we call as a simple machine called microprocessor. It takes input from the outside world, processes it as per the instruction given by us, and gives you the output here. And along with it, it has a memory unit, because whenever you are calculating data, whenever you are doing some kind of programming, you need memory. So that memory unit is to be attached, and that is the complete architecture of any microprocessor system that you have. Another similar concept that you have here is, the same concept but different representation is you have a CPU where you have ALU registers and all the control units, the input output, because you want to connect with the world. The microprocessor has to connect with the world. So that is the reason you have input output devices connected with the system. And of course, memory has to be there for storing. So, and the bus, as we have just now talked, buses are nothing but the tracks through which the data gets transferred from one place to the other place between the microprocessor and the memory and so on. So these are the three types of buses or tracks or parallel lines which will take data from one place to the other place is something which we call as a bus, right? So coming to the various types, I'm sure some of you might be aware of this. The two types of microprocessor or the processors that we have can be categorized into CISC and RISC. So CISC is nothing but it is a complex instruction set type where you have a lot of instructions, right? For a single work, you will have various instructions. which will be doing a particular job. So that category of microprocessors which have a exhaustive instruction set where multiple instructions will be required to perform a simple function is coming under the category of CISC. And about RISC, it is a modified version of CISC, because remembering those many instructions is really difficult. So then people thought of having a reduced instruction set type of processors which had very few set of instructions, and one instruction will do multiple jobs. So if you compare a CISC, a microprocessor 8085, which is an 8-bit microprocessor, comes under the category of CISC, where you have more than 100 instructions, right? And RISC are those advanced versions of the processors where you have very few instructions, and one instruction is doing multiple things at one go. So PICs, like the programmable interrupt controllers or programmable interface controllers, they are the ones which come under this category where you have hardly 20 or 25, 30 instructions in the complete instruction set. So it's easier to remember those instructions, and it's of course easy to program. So any processor that we have today can be divided up into these two types, whether it is coming under CISC category or RISC category, can be easily found out from the number of instructions that you have for that microprocessor for programming, right? Coming to the next aspect of it, the generations. So because everything has seen advancements, so when we are talking about processors, with VLSI technology coming in and lot of advancements getting into the IC fabrication, we have been able to make the processors much more compact and much more better. And of course, speed-wise, we have been able to improve quite a lot. So based on that, we have various generations. So there are till date 5 generations that we have. Coming to the first generation, which started from the first Intel microprocessor, 4-bit microprocessor, 4004. It was the first generation which was ranging from 1971 to 73. And this was the period when Intel first created the first microprocessor. And the clock speed was 740 kilohertz. So clock speed is the operation, the speed of operation of that processor was 740 kilohertz, which was quite a lot at that point, in that times. So apart from this Intel's first microprocessor, there were others which got made. Intel made its own 8008, which was 8-bit microprocessor. Then we had National Semiconductors, IMP16 coming in. So various companies were actually competing that time. And this was the time when we had these processors coming into market and flourishing it. Then we moved to the second generation. Now, why did we move to the second generation? Because we thought the speed was not very sufficient. At the same time, we thought that, we need to have better computation facilities because, we always want more. So we from there, we moved on to the second generation where which can be taken from 73 to 78. And here, very efficient 8-bit microprocessors were originated. You can see Intel 8085, which is the world-known microprocessor. Even today, we have it in our course, despite maybe 5-6 decades are over of its generation. We still study this in our curriculum because it was the most basic microprocessor that was there and was very widely used. So many people never wanted to change from 8085. It had so many characteristics and better features. Apart from Intel 8085, we had other companies like Zilog's Z80 coming into the market, Motorola's 68 series, 100 series coming into the market. So they had faster speed. They were little costly because they were based on a new fabrication technology, as I said. So we wanted speed. We also, there was also advancements in the fabrication industry. So, people were really working towards that to increase the speed and make it better performance. So there was the second generation. Coming to the third generation, which was very short-lived. As you can see here, only 2 years. In this, the 16-bit processors were created, and that used HMOS technology. So the examples during this period, the processors which were developed were 8086, 80186, 80286, and so on. So here the concept of pipelining also got developed. Instructions to be made in queue and to be executed one after the other. So these were some of the good examples of the third generation microprocessors. Coming to the fourth generation, which ranged from 81 to 95, we had HCMOS fabrication technology coming in, and this generation had 32-bit microprocessors. So Intel's 80386 was one of the most popular processors at that point in time, and Motorola, its competitor, also had been improving on the same lines and giving a competition, tough competition to Intel. Then we came to the last, or the fifth generation, which can be considered to be from 95 till date, where we have all the 64 processors which we see today. So that includes Pentium, Celeron, dual and quad core processors. So I'm sure many of you know about the companies which are making these processors, but for totality and for understanding of everyone, I want to kind of reiterate here. Intel, of course, a few of the fifth generation processors are made by Intel. You all are aware about it. So it was the first Intel Celeron which was developed in 1998. It was based on Pentium 2, and now we have come to Core i9, which you all are aware of, and you know better the specifications, you know better than anybody of us, right? So Motorola started with 6800 series microprocessors in 74 and was giving tough competition to Intel during all the generations, as you have seen. And it was till now we have 620 microprocessors, PC 620 microprocessors that has been given by Motorola. Then we had Pentium. Pentium was introduced in 1993, and since then we have a lot of advancements that have come in Pentium. Today we are sitting on Core i series processors of Pentium, which was developed in 2011. And then we have Xeon in the market, which was a 400 megahertz Pentium processor from Intel, which actually revolutionized everything. Most of the workstations that you have and places where you need to have lot of computations and lot of calculations, they use Xeon processors. Today, the advancements happened, and from the first Xeon processor, we are into dual core Intel Xeon processor right now, which is working at 3.4 gigahertz speed. As you can see, a lot of improvements happening around. And now coming to how do we select a processor? Of course, it depends on what is your work. What is your application? It actually depends on what is your application, and do you have that processor which has those features suitable for that application. So that's the crux, that's the basic understanding. And if it is like exhaustive, very calculation based application, you need to have, of course, more than 12-bit processor, 32-bit processor, or 64-bit processor. But if it is like a general application, 8-bit, 12-bit, even 16-bit processors are more than sufficient to carry your work. So mostly it depends on the kind of application that you are handling, right? So speed and power, both these things decide what kind of microprocessor do you choose for your application. Because if you need speed, it will consume a lot of power. If you do not have that much of power available, you will have to compromise on the speed. So both there is a trade-off always. Okay. Coming to the advantages, as you can see, of course, high processing speed, size, easy maintenance, flexible. Why? Because it can be connected with various peripherals, right? Microprocessor is just the brain of a system. You have to connect to the IO devices, you have to connect with the memory and integrate all the system together so that you are able to get a complete complete system, right? So it's more flexible. You can attach any required memory, any required IO interface, because it's not fixed. For a microprocessor, you just have the brain, you have to connect different things and you get a system out of it. Now, that's the reason it is flexible and it can be changed as per your requirement. So it is more general in nature, but the disadvantage is, of course, it is a large board size because you have to integrate a lot of things together, you have to connect it, so the board size gets larger. And of course, due to overuse, there can be overheating because the peripherals have connections, and the most of the processors do not support floating point. Floating point operations, are very calculation exhaustive, and hence they are not being supported by microprocessors many times, right? Now, coming to another category of processors, which you call as microcontrollers. Many of third-year students would be knowing what is the basic difference between a microprocessor and a microcontroller. So a simple diagram will explain you this. A microprocessor is nothing where you have a simple machine where you have to connect all the peripherals from outside. But a microcontroller is a simple machine where you have everything on a single chip. So it's actually fixed, or you would say all of these things are on a single chip. So this is your microcontroller. So what is the basic difference? In a microcontroller, we actually know an application. We know for what are we using this microcontroller, and then we kind of design a system on chip. So that is the reason it is called as a system on chip also, or SoC. It is a mini computer which is designed for a single task. So as you have seen, microprocessors have greater flexibility because you can think of an application, and accordingly you can make your own permutations and combinations. You can use amount of RAM and ROM required, and accordingly you can make a system. But for microcontrollers, you actually pre-decide, the application well in advance, that I am trying to make a micro for a particular application. For example, anybody who would like to name the examples or the products which are based on microcontrollers today, any general product that is based on, I would request kindly put it in the chat box, those who know the applications of the microcontrollers. Quickly in the chat box, tell me what all are the applications of the microcontrollers. What are the machines that are basically using microcontrollers in present world today? Quickly in the chat box. Till then, I would quickly go to the basic difference because we are running short of time. I'll quickly close this. Microprocessors and microcontrollers, the basic difference is that everything is on a single chip in microcontroller. And here in microprocessor, you have everything which can be integrated and which can be connected to the processor separately. So it's more general in nature. You can have various applications based on your based on the microprocessor. Here, the applications are pre-decided. You cannot change the framework of the microcontroller. It's decided well in advance for what are we trying to use this microcontroller, and accordingly it is programmed, and the memory and everything is decided during the fabrication stage of the controller itself. So the various applications. I'm sure you are aware the complete embedded system industry is flourishing today. Anything and everything that you use in your daily life comes from a microprocessor or a controller or an embedded system. So be it television, mobile, printers, personal computers, or anything, even in medical industry, all the sophisticated instruments which are used to detect maybe the cells or the or basic other body parts, they are based on microprocessors and microcontrollers. So anything and everything that you see today around you is made of the processors. So that is how important it is to study, and this is the reason why we are studying this as a course of an engineering curriculum also. And apart from that, it has a lot of scope and flexibility for you to make projects, and that's the reason we are today taking you through to a very new type of ARM Cortex processor, which will be taken up by Gaurav, Mr. Gaurav right now after I close the session. And it will be more on the practical aspects of it and understanding the concepts of ARM Cortex microcontroller. Okay, processor, sorry. So that's all for today from my side. Thank you all for joining in. And I see hardly 50% of the students who have joined. I don't know the reason why, but we had 92 registrations and we only have 45 of you here. So maybe we'll have to speak out and see why this less strength is here. Now, I would hand over the stage to Mr. Gaurav, who will take you to the sessions on further on the processors. Okay. Thank you all for patience listening. I think I was able to revise the concepts in 30 minutes of time, and have set the platform for your understanding further on a new processor. Thank you all for joining in. Mr. Gaurav, are you there?
Yes, ma'am. Good afternoon, everyone.
Thank you, Mr. Gaurav.
Yes, yeah. I'll take it from here. Thank you so much, ma'am.
Thank you.
Okay, students, good afternoon, everyone. Before we begin, I have a couple of requests. Okay, so we'll just lay down some rules for the workshop, because since we are connected online, I want to keep track of how much you are getting and how well things are going. Okay, if there are any queries, please put it in the chat section immediately. I have that open in front of me. I also want you all to keep the chat section open for all those who have connected via laptops. Please keep your chat section open so that at any given point, if I am asking a query, if I have any other questions to make, you can very quickly give your replies there. Okay, most of these questions are going to be yes and no type questions or one-word questions, one-word answers. So please be ready there. Okay, all those who are on laptop, all those who are on mobile can stay at their home screen, and then as the question is being asked, you can go there and answer. At the very beginning, sir and later on ma'am gave an introduction to me and my company. So we are a technical training company. We also develop our own products. Like ma'am said, we are doing an intern. We have a couple of interns from your college who have cleared multiple rounds, multiple technical rounds, and now they are working with a team of interns under us for an electric vehicle project. So we have conducted several workshops at your college before. So we have had a very good relationship with Bharati Vidyapeeth College. And now for the next 3 days, starting from today, we are going to look at embedded systems. Ma'am gave very, detailed introduction to how a controller and processor, okay, what are processors? Okay, its architecture and how to, what are the point of differences between controller and processor. And, at one point, ma'am said that processors, controllers are nothing but processors with some peripherals, and that is what it is. So both are basically processors. One is a standalone system, other comes with some peripherals. And after a small introduction that I also wish to give, we will begin with our practical sessions. I'll introduce you to the NXP kit, okay, the kit that we are going to use, which is an ARM controller. We will build a small project today, and we will just look at how things function at this particular platform. Our compiler, I'll talk about the details of the project later. Tomorrow, what we are going to do is we will work with input and output devices. And on day number 3, which is day after, that is where we will look at sensor-driven systems. So we will replace our basic input devices by some sensors, and we will try to get the outputs. The idea of this workshop, or the objective of the workshop, is to make you realize that if you have any project idea with you, making a rough prototype is very easy. It doesn't involve much cost. It also doesn't involve, it doesn't take too much time. Only thing is you need to know how to make that project, and which we will be discussing in the next 3 days. Once you have that idea with you, our expectation is, both the college and us, what we expect from all the participants who are attending here is to make projects. To put it very simply in front of you, is to make projects. It could be small projects. You can make multiple small projects, integrate them together to make a slightly complex project. You can then have discussions with your teachers. You can have discussions amongst your friends, and then think of a slightly bigger idea, and then put all the knowledge there and make your project. What is the process of, after making a project, to convert that into papers and potentially patents and competing in competitions? Those are the things we will discuss on day 3. Now let's begin. I'll just share the presentation. Very quickly, if one of you can just unmute yourself and say if it is visible to you all, we will just begin. Is it visible?
Yes.
Yes, sir.
Visible, sir.
Okay, awesome. So my name is Gaurav Singh. I run this company. Just give me 1 second. I'll switch off the camera. Okay, it is. Yes. So this is a big list of content. We will try and see how much we can cover. Like we discussed, this is what we do. We are a technical training and product development company. WEORG Education deals with the training part. It deals with trainings for all age groups, right from 8 years to 80 years. Product development side is managed by Dalvik apps, which is where we have both hardware and software projects depending upon our client requirement. That is what we develop here. Okay, let's start. Before we jump to embedded systems, let's start with electronic systems. Okay, what do you mean by an electronic system, and how do we design this electronic system? So first is, what do we mean by an electronic system? An electronic system is nothing but a bunch of components that work together to give you one one particular desired output, or one or more. If there are multiple outputs expected from a system, then it could be one or more desired output from the system. Now, the word desired is very important here, and I'll tell you why. If you have, okay, I'll just draw a couple of things here. Okay, so if you have, say, a mic with you, okay, assume it is a mic, okay, and this mic is connected on the other end to a speaker, okay, which produces sound. Now, you all have experienced, and say, suppose this is me standing in front of the mic and talking. Now, you all have experienced a very unpleasant sound coming from a mic and speaker system, right? A very disturbing noise, you know, key, ka, some really bad sounds coming from it. That unpleasant noise is also an output from the same system. It is an amplified version of the noise created within the system. But that is not the desired output. The desired output is only what I speak should be amplified and made available to you. Okay. Hence, the word desired is very important when we are talking about designing of any system. Now, how do I design a system? We will simply try and put a few blocks together and see if we can create a generalized block diagram for any electronic system. Now, in the previous session, ma'am gave a couple of block diagrams talking about how microprocessor and its architecture or its functioning can be represented in a pictorial manner. I will try to do the same thing. The only difference is I'm going to draw. So my block diagram is going to be very shabby. Please try and understand things. Okay. I'll just put a few blocks in front of you. You can just go to the chat section and tell me if there are any new blocks that you can think of. If we are trying to design an electronic system, the first thing.
Excuse me, sir.
Yes.
Sir, we are not able to see your drawing. I mean, the figures that you are drawing.
I have. Can you see a rectangular box right now?
No, sir. We are able to see your first slide, embedded system development only.
Okay, just 1 second. Can you see the slide now?
Yes, sir.
Can you see a blank slide right now? General block diagram slide?
Yes, sir.
Yes, sir.
Okay, okay. And can you now see a box drawn at the center?
No, sir.
So whatever I write is not visible.
Yes, sir. What you're drawing is not visible.
It is not visible. Okay. Just give me 1 second, okay? Can you see the example slide right now? Yes, anyone?
So we are able to see the introduction to SOC.
Okay. Can you see the introduction to SOC at least right now?
Yes, sir.
Yes, sir.
All of you can see that, right? And the drawing and whatever I write is not visible.
Mr. Gaurav, are you using the whiteboard for the same?
No, ma'am. I have a digital writing pad connected.
Okay, okay.
Because
So,
I can see those things at my screen, but then I think it is not getting shared. No problem. We'll continue without those things as well. Okay. Now let's talk about SOCs for now. Okay. Now what do you mean by SOC? SOC stands for systems on chip. Okay. Now what do we actually mean by that? So, like ma'am said, we have our microcontrollers that have a processing unit with peripherals connected. Okay. SOC is basically the same things put together on an IC. Okay. So if we have a set of components that can be put on a chip that perform a particular function, we name it SOC. What are the advantages and disadvantages of doing this? The number one advantage of making a SOC or a systems on chip is we make a very compact system. Okay. Now, if you open your phone today, you will see there are a lot of black color ICs there that have multiple functionalities. Now, how are we able to do those things? It falls under the category of VLSI, which is very large scale integration. SOC is a product of VLSI. We make small things, we make things smaller, okay, comparatively smaller as compared to having individual components. Also, since most of these things are within an IC, we do not have to physically connect them while making the system or assembling the system. So suppose you decide to make a project today, you go to Lamington Road, you buy your own components, and then you take using some jumper wires, or you create a PCB, you etch it to have tracks and then solder the components. But if you buy an SOC or an IC that has all the components within it, you don't have to do any physical connections there. And that is the biggest advantage of using SOC. It is not just you're reducing the size, you're taking away the connection part completely, which reduces the time of making a system very less. Okay, it makes it very short. You can rapidly create your prototypes. Any other you can very quickly put it that you can think of. So 3 I have said. One is the size of the system becomes small. When I say system, it means electronic system. Size becomes small. There are no physical connections, and there are also the time to make a system also reduces. Okay. Any other advantage that you can think of? You can very quickly put them in the chat section. I see no answers there. That is slightly any advantage that you can think of having a smaller size system, having to put things in a IC. What would be an advantage of that?
Power consumption.
Apart from the 3 advantages that I have said. Yes, anyone? Put it in the chat section. You need not unmute yourself and say. You can put that in the chat section. Okay, while I wait for your advantages, let's also look at the disadvantages. One of the biggest disadvantage of SOC is that if you create a system with ICs, repairing a system is virtually not possible. You can replace ICs, but you cannot repair them. Okay, so that adds to another disadvantage, which is it adds to the cost of maintenance. Okay, so maintaining a system for a longer duration becomes costly. But okay, but tell me one thing, now that we are discussing cost, will my cost of production of a system increase if I have SOCs, or will it decrease if I have SOCs? SOC is system on chip. If I put things together on an IC, if I put 10 components together on an IC, will it increase the cost of the of production, or will it decrease the cost of production? At least you can write increase or decrease in the chat section. I just want to see if will it increase the cost or will it decrease the cost? Yes, everyone in the chat section, just write increase or decrease, increasing the cost or decreasing the cost. What will be the effect if we take components and make an IC out of it? Govind says it will increase. Pranit says it will increase. Apurva says no, it won't increase, which means it will decrease. Okay. Rutuja says it will increase. Okay. So the answer, so all of you are right here. All of you. The cost of production will increase if you are making a single unit. But if we set up an assembly line where we can make hundreds and thousands of units of the same design, then we can bring the cost down. Okay, an example for that is your mobile phones. Okay, 2 decades ago, in early 2000s, you had a, if you bought a 10,000, 15,000 rupee mobile phone, it had a very bad camera. Okay, it had no other features, only game of snakes and a ball game was available for us. But if you look at a 5,000 rupee mobile today, it has tremendous features. Probably not a very smooth mobile phone, but feature wise it has everything. So the cost of production will increase if you're making less units, but if you're making hundreds and thousands of units, then it will decrease. Now, a couple of advantages that have come, I'll quickly address those as well. One is Yash saying the power consumption reduces, same is by Apurva, and both of them are right. And why? I'll also tell you why power consumption reduces. The main reason is there are no physical connections. Okay. Now we all completely disregard the internal losses when we are designing a system on paper. Okay, when you are doing your electrical networks and EWT, wave theory and all those things, we completely ignore internal losses of a system, but they are very significant. Okay, so since I personally have been involved in a couple of circuits that have made it to the market, I can very well tell you that these internal losses that we completely ignored during our engineering calculations are very important. They are very significant. And since we do not have any connections there, the internal losses reduce. That losses in terms of power, current and voltages reduce, and hence you have better you have a more efficient system with you. Reliability of, okay, Apurva also says reliability increases. Okay, reliability, yes, it will increase since all the system reliability is same, and also if you have 10 products that have come out of your system, 10 ICs, all of them will have same level of accuracy. So it will not vary, because they all have been made through the same system with a machinery that designs them. So your reliability is more, your accuracy across hundreds or thousands of products will remain same. You'll have some ambiguity, but that can be completely neglected. So yes, good. I see a few of you answering. That is very good. Moving ahead. Okay. Now, Gordon Moore, ma'am, also talked about his contribution to processors and embedded systems and electronics in general. And he said Moore's law, a famous Moore's law, where he said the number of transistors on a particular chip would double every 18 months. That is, with advancement in fabrication technology, we can actually put in more and more transistors or more and more basic elements in unit area, which will help us increase or enhance the feature and functionalities of a system. So I just thought I'll add this slide. Let's also talk about, okay, before we go into the coding structure, I just want to talk about embedded systems first. So can anyone in the chat section, I have given you a definition for electronic system where we take a set of components and we put them together in such a way that we get the desired output. Can you tell me what could be a definition for embedded systems? I don't want a theoretical definition. I just want an explanatory one-line answer to what an embedded system is. Yes, anyone? I'm looking at the chat section and waiting. Okay, can anyone tell me what is embedded systems? Okay, forget about what do you mean by the word embed? What do you mean by the word embed? Yes, I'm sure you all are connected to this particular lecture via internet, correct? So you can very quickly Google an answer, but I want an answer for this. What do you mean by embed? Because embedded systems is something that you're going to listen for the next 3 days at least, if not entire engineering curriculum. So what do you mean by embed? Okay, Apura says to fix. Okay, anything else? You can improve on that. Fix to something. Embed means to fix. Okay, anything else? Okay, can you use better words? Slightly better words. What do we mean by embed? Firmly, I think you're trying to say firmly attached. Yes, firmly attached. Yes, anything else? So embed something coding embedded in hardware. Okay, you're talking about, okay, Rajesh, you're talking about embedded systems. I just want to understand the meaning of the word embed. Say insert, okay, insert. So embed means to put something on one layer of, say, bread, and you put some liquidish thing on it, say mayonnaise on bread. Okay, embedded is to implement. Okay, when we are talking about, okay, embedded systems, we are talking about a hardware system, okay, controller with peripheral devices, input devices, output devices, memory, clock. You can have other sensors there. You can have, you will have your power supply unit. All those things put together. That is your hardware system. And when you put a software on it, when you put a code, when you put a program on it to run that particular hardware system, we call it embedded systems. Okay, a slightly better definition of that would be when we take a set of components, okay, and we write or we embed or put in an applicable program in it. The word applicable is important because not all hardwares support all different types of programs. You need to find applicable or programs that can fit into a particular system, and then the rest is same, that you get a desired output. Now that being said, all I see close to 40 odd students here. All of you are engineering students. Now think about this. Okay, very quickly, can you all? So all of you are from EXTC. I'm assuming that, and most of you who will get placed in, those who are in third year next year, those who are in second year after 2 years. wherever you get placed, most of you will get consumed in the IT sector, which is doing programming or coding for one or the other company. Most of you, a few of you might still be working with hardware, but most of you. Now, can you tell me what is the need of a software in a hardware-driven system? Why do we need software in a hardware-driven system? I want you all to answer this, because that is what is going to govern your career. Okay? Can you tell me what is the need of software in a hardware-driven system? Okay, all 5-6 of you who are answering, and there are at least 30 odd more people, 30 to 40 more people who are here. Can you tell me what is the need of software? Why are all the jobs, if not, why are all the jobs, okay, in the IT sector, most of the jobs that come your way, nearly 90-95% of the jobs that come to colleges, or even if you apply off campus, are in the IT sector. Okay, Apurva says, Apurva, can you also reply and tell me if Apurva is he or she? Apurva, I mean, if you're a boy or a girl, because Apurva is something. मेरा एक दोस्त है who's a boy who's also Apurva.
She, sir.
She. Okay, so I can address it that way. So Apurva says that to guide a system in the correct manner. Okay. To operate the device according to the user. Okay. Okay. Who's this? Ketan Jadhav. Correct. Correct. And any other answers? Because all of you, most of you, 90% of you are going to work in and around softwares. So what is the need? Why do you think that even TCS and all these big companies are looking for engineers from EXTC or electronics or any other branch that doesn't have computers knowledge as a core of it, but then you get hired in an IT company? Okay, anything else? Yes, Rajesh says to control the hardware according to our needs. Okay, to operate the device, to guide the system. Anything else? Anything else? Think, because तुम आगे चल के उसी में जॉब करने वाले हो. Okay, so think about that. Why do we need software or program or a code in a hardware-driven system? Okay, a few of you have answered. I'm looking for more people to answer. So Apurva, Ketan, Rajesh, Tehreen, if I'm pronouncing your name correctly, hardware and software are interconnected. Okay, to maintain data. Shweta says, Sushant is to integrate them both. Okay. Assembly level language to high level. Ritu. Okay. Anything else? Anything else that you can? Any other answer? I'll just take I'll just wait for 1 more minute. I need one pinpoint answer, and I'm sure one of you will definitely give that answer. What is the need of software in a hardware-driven system? Because that is how we define embedded systems. What is the need of software in a hardware-driven system? Very quickly. For automation, okay, automation. Okay, automation is correct. All of you are correct. Okay, all of you who have said that we need to integrate them, we need to make it more conducive to us, which is change the output depending upon the user. That is what it is. I'll just give you a few points. Okay, I'll just give you a few points while since I'm not able to write on my whiteboard and make it visible for you all, I will also be typing whatever I'm writing. So now just wait. Okay, now just wait. It says to maintain. Okay, what do you have said? To maintain sustainability of hardware systems. Okay, now imagine this. Okay, imagine this. You have a bulb. A normal LED bulb, which is controlled by a switch in your house. Okay, it's a pure hardware system. All the wirings are concealed in the wall. You switch on the bulb. Okay, you switch on the switch, the bulb starts glowing. You switch off, it goes off. Okay, very simple system. Now, if I can add a software to this, I can add new features. Okay, feature number 1, if I have a sensor there, I can very well, I can very easily walk into the room and expect my light to switch on. Okay, it will detect whether we have people inside the room, and then I can switch on the light. So जो पहले switch via switch हम लोग switch on and switch off कर रहे थे, now I have made it automated. So like you are saying automation, yes, this is how you can add automation to the system. Now you can also add new features to the system. Now white light is nothing but RGB, red, green, blue, all three of them switched on in full intensity. That will give you a white light. That should give you a white light. But if I have a software that controls my LED, I can change my shades in between. Now all of you have gone to Photoshop, if not Photoshop, to Paint. Okay, Paint pe jaake you can, if you want to choose a particular color from the color palette, you can choose. If you want an intermediate color, so you can actually browse from white to black, sare colors beech mein hai, and you can choose na intensity of your green, suppose light green, dark green, black content in green or white content in green, and all those things. Mixing of colors, all the intermediate shades can now be made available to you. Correct? So now I am typing. What is the advantage of having softwares in a hardware driven system? Number one is you can automate, automate or enhance existing features. Okay, you can enhance the existing features because switching on and switching off in an automated manner with the help of light. With the help of sensors. You can also have an intelligent lighting system कि अगर बाहर की light fade out हो रही है, which is sun, then धीरे-धीरे मेरे घर की light अपने आप strong होने लगेगी. Correct? So you can have smart lighting systems in that manner as well. You can enhance the existing features. You can add more features. And the third thing is, if you want to make changes in the system while the system is on, my point is, suppose system तुमने set कर दिया है, okay, and now if you want to make changes कि यार तुमको white light पसंद नहीं आ रहा है, you want yellow light or red light, you're just making changes in your software. You're not bringing in a new bulb and making changes. So altering output is almost free. Okay, so there are three basic reasons. Number one is you can existing features को हम better बना सकते हैं. We can add new features. And the third point is if you want to alter the feature midway after the project or the product has been deployed or put on, you can make small changes without actually changing the assembly. That means you can do it free of cost as well. अगर तुम खुद कर रहे हो तो you can do it free of cost. There are no hardware costs, there are no compatibility issues, nothing. Okay, so these are some advantages of having hardware systems which are supported by some or the other software. Now, let me just go to presentation. Yeah. So talking about coding structures, there are three basic types of programming. Okay, I'm not talking about types of languages. I'm talking about approaches of programming. Number one is hex programming. Okay, hex programming is where you have your machine level or assembly level programs, which is in hex or which is in ones and zeros. Okay, difficult for us to understand, and even your basic programs will have multiple lines of code. And it is very difficult for us to understand or make mistakes or correct mistakes, find mistakes in a one and zero program. Hence, what we generally use is the higher level program, which is higher level programming approach, which is using languages in English. Okay, now that could be your C, C++, Java, Python, whatever different things you use, HTML, CSS, and all those things. They all form an approach of programming which is the higher level languages. Okay, it is in English, it is easier to understand. They are always supported by a strong compiler. So compiler का काम क्या होता है, compiler's job is not to find mistakes in your code. Its job is to convert your higher level program into an assembly level or machine level program. But in the process of conversion, if it finds कि कहीं पे कुछ mistake हो गया है, okay, it will give you errors on those lines. You can go correct and then compile your program. The third type of programming, which is the API style of programming. Probably on day 3, we will do an API driven project. So APIs are nothing but hardware based functions that a system already has. Okay, these are built-in functions that your system has to drive any hardware or software also. They're built-in functions to drive some components in your system. The advantage is you don't have to code that particular component again and again. Now, when we do a project on day 3, I will talk about APIs again. You all, I'm sure you all understand what functions are, right? If कोई चीज है जो बार-बार करनी है, but we are not sure whether it will be needed or not, instead of writing it in the main, we write it outside. We call the function if need be. Correct? So APIs are nothing but functions जो लिखने भी नहीं पड़ते, जो हमारे सिस्टम में पहले से होते हैं, हम बस उनको कॉल कर लेते हैं. We do not actually code for them. So we will look at one of the examples on day 3. Couple of blank slides. Okay, ma'am has already discussed about controllers and processors. If you all want, you can just have a look at it. Processors are thinking elements. Controllers are thinking elements with some peripheral components attached to them. So controllers can be used directly for rapid prototyping because uske around system ke components hain. Microprocessor is just a thinking element and computing things within it. All the other components need to be selected depending upon application. So last point dekho, microprocessor is more general purpose system and your controller is more task specific. Controller के साथ में flexibility नहीं मिलेगा. Processor के साथ में you'll have all the flexibility to add new components with different specifications as per your project. Now let's talk about the Mbed platform. Okay. Now this is not a spelling mistake that I have made at the top. It is MBED, Mbed. So we will now what we are going to do is I'll just take you through a couple of slides and then we move online. Mbed is a platform that has been developed. So all of you might have heard and used Arduino in your engineering life, right? Arduino is a very small platform or a very small project building board, which has at Mega IC, which has a controller, and you can do some stuff. You can download the software, write your programs, get your outputs checked quickly. Mbed is one such platform which is available online. So you need not download anything. You can, just like your social media websites, you just go there, make an account for yourself, click on compiler, write your program and then start compiling. जो compilation होता है, if it is correct, you get a downloaded file on your computer. With the help of the boards that you can have with you, you can just copy it in the board and check it. I'll जो मैंने अभी बोला बहुत confusing था. Give me a couple of minutes. We will do it live and we will see. Okay. Now, when we go to the platform, we will now go to the platform. But before that, you can see that these are the various boards that are available that Mbed supports. Okay. यहाँ पे हमको दिख सिर्फ 6 रहे हैं, but it can actually support more than 20 boards, if I'm not wrong. Okay, with different capabilities. Some are good for Ethernet based projects. Okay, some are good for sensor based project. Some are smaller in size, larger computation capabilities. So depending upon your project, you can pick and choose which one to use. We are going to use this product, second row first product, which is FRDM, Freedom KL25Z.
Can see the slide.
You can't see the slide. Where are you
Sir.
stuck?
So it is showing only coding slide.
Still on the coding slide. Okay, let me restart this. Can you all see my slide right now? Whatever is open in front of me. Yes, one of you can just unmute and stay with me for 1 minute. Can you all see that? Yes. Now please wait. Huh? Please stay unmuted. General block diagram slide right now.
Yes, sir. General block diagram.
Okay. And can you see anything written here in red?
Yes, sir.
So now you can see whatever I write.
Oh, yes, sir.
All of you just go to the chat section and write a yes, so that all of you can see, and then I'll very quickly go ahead with this. Yes. In the chat section. Awesome. All of you can see. So I'll very quickly make this block diagram because this is important. Okay. At the beginning, I said when we are designing a system, because that is what we are going to do from now on. I was just going to jump to Mbed, but before that, I'll just show you how to make or how to think of making any project in your curriculum from now on. Okay. At this center, if you're not able to see anything, please, one of you can just unmute and tell me. At this center, you have your microprocessor or your microcontroller. Depending upon your project, you can pick and choose controller processor and then which controller processor to use. Okay. Now, as a general user, we are only interested in set of input and output components. Your input components could be, your keyboards. Okay, keyboard. Your input component could be a switch. It could be microphone. Okay, it could be anything, right? And you will have a corresponding output. So for keyboard, you have a screen. You could have a motor as an output. You could have a light or an LED. You could have a speaker. Okay, my handwriting is very bad, but you can understand, right? As a general user, I am only interested in, because you will have your friends and cousins who buy phones who talk about कि उसका display कैसा है, कितना बड़ा है. They talk about what are the how good is the camera. They talk about which controller processor या कितना processing speed है, what is the gigahertz of the processor that is inside. So as a layman, we are only interested in these three blocks. Okay. But as engineers, okay, as engineers, we need to look at the designing slightly more closely. So one element that we must have between our input and our microprocessor is called the interfacing element. Just one second. Interfacing. So interfacing का मतलब होता है, suppose this is analog, but my controllers will only understand digital. Okay, so interfacing will take care of these conversions. Interfacing will also take care if my signal is very small in amplitude, but itna chota signal like that I'm not able to get it. So I can have my amplifiers here, I can have rectifiers, I can have all those stuff. So they are shaping my signal in such a way that my controllers can read it well. So I have my interface ICs here. I will also have interface ICs between my controller processor and my output. So yahan pe bhi you will have your interface ICs. Okay, with this at the very beginning we also discussed, ma'am actually discussed those things, that in a system you should have your clock, you will have your memory element, and to drive all these things you require a power element. Okay, and obviously all these blocks are connected. Okay. Your connection to your memory element can be two-sided because you are also reading and writing in the memory. All the others follow a flow, and then you can control your entire system. Now, depending upon what you're actually designing or depending upon what you're actually making, you can add some of the blocks here. Okay, like in the input section, your inputs may involve sensors. Okay, you may need some calibrators, you may need some data coming from outside, so you may have Wi-Fi, or let's not call it Wi-Fi, let's call it wireless transmission and reception units. So depending upon your system, you can pick and choose which blocks to keep, which blocks to avoid. But this entire assembly that you see in front of you, this block diagram that you see in front of you, more or less will take care of most of your embedded systems or most of your electronic systems. Okay. Now, so this is how Mbed.com looks like. Can you all see this? Can you all see the website? One of you can just let me know.
Yes, sir.
Yes. Okay. On the side, I will also start my camera. Do I not? Okay, I'll do that later. Let's stay here. So this is how your Mbed environment looks like. I'll just take you through all the options that we have here. Okay. You see, this is my login account. Okay. My programs, my activities, profile, and all those things. I'm not going to go in these things. Then there's a compiler option where I can click and go ahead and continue with my programming. Now, before I go there, we can very quickly look at what this Mbed environment is all about. Okay, so you have a lot of hardware, software, documents, case studies, support, which is basically if you have a problem, you can just post it here and somebody replies. You have a blog where you can also become a developer and post, and then a lot of online events these days are happening. You can be part of those things. You can pay a very nominal fee, attend conferences, and all those things. Okay, we will very quickly look at all the things. Let's, like I said, there are a lot of boards that this supports. So let's go to boards first. Let's see what are the various boards that we have right now. Okay, now you can see I said 20, there are 167 results. Okay, not all of them are available in India, but you can just scroll through it and see that there are a lot of products, and you can take any of these. You can actually take any of these boards. The programming can be done in the same environment. Okay, you just click on compiler. You can open a compiler here. Okay. And like I said, the programming bit is slightly new. I mean, slightly different from Arduino or any other desktop-based downloaded IDEs. I will just take you through one of the programs today. Okay. What we will do is we will. Okay. Before we start, I'll just stop the screen share to show you what the product looks like. Yes, so I am online now. If you all can see me. Can you all see me? Yes, yes. Just write a yes. Can you not? Kuch to bolo, yes, no, some answers. Okay.
Yeah, they can see you. They are putting it in the chat box.
Okay.
Yes, sir.
So this is the free scale product that okay, it used to be Freescale, now it is NXP product that we are talking about. This is the kit that we are going to use. Now, unlike most other kits that you have seen in your life, okay, this particular board has two USBs. Now, can you see that? It has two USB ports. One here, when I hold it towards me, the one on the right is the programming USB board, USB port, and the one on the left is the HID. HID is human interface device. So once the programming is done, and if I'm using this, if I'm using any of the sensors which are there on this, then I will use the other board. Depending on projects, we will change the USB. I will let you know those things. Now, how we do it is, I will very quickly do a small project. When I'm doing the project, I make sure that my USB is not connected, okay, while typing the project. But when I'm downloading it, I need to connect. Okay, I'll take you through the entire process. Just stay with me. First project is slightly difficult to, slightly new. But once the first project is done, you will have a fair idea of how to go about it. We will be doing at least 4 or 5 projects during this course. So you'll get a knack of how the things really work. Okay, let me start sharing it. Yes, so let's be here. Okay, so this is the compiler screen that you have in front of you. When you all go on mbed.org, on mbed.com, look at this particular corner. I have the FRDM KL25Z board selected with me right now. But when you all go, if any of you have laptops with you, and if you can just go on mbed.com, create a small account for yourself, sign up, and then when you go to the compiler option, you will have a blank section here which says no board selected. When you have no board selected, that is when you can click on this. Okay, you can go to the boards option again. Okay, you can go to the add board option and then continue with your program. Since I have a board selected, I won't do that. Okay, now once you select the board, you will have, so these are the projects that I've already done. Okay, let's click on new. Okay, let's click on new. I'll click on new program. Okay, it gives me a default program which just the name of the program is Mbed. Name of the program is Mbed_Blinky. Blinky means blinking the LED on the board, switching on and switching off of the LED, okay, which is present on the board. And it also talks about a template and all this. Okay, those things are not required. Let's just click on OK and see what we get. Okay, we are just creating a default program. We have not typed anything. Okay, we get 2 files here. One is the library file and then is main.cpp. We will double click on that and we have a small program in front of us. Okay, let's just read through this. So this is just like your iostream.h. Mbed.h is the header that enables all the basic input output options for you. Okay, we have declared one variable which is of the name myLED, and the myLED is a digital output connection of the type. So this is the type of the variable, this is the name of the variable, and this is where the connection is done. It is connected to LED 1. Okay, on the board we have 3 LEDs, red, green and blue. LED 1 is the red LED. Okay, so I will just switch on the red. Okay, what I'm doing here in the main section, my LED equals to 1, which means I will, okay, logic says equal to 1 matlab I will switch on. I will wait for some time. Let me increase this to 0.5. Okay. Then I will switch off. My LED equal to 0 means I will switch off. I'll give a logic low to that. And then I will again wait for that. Now these two operations, switching on and switching off, separated by a wait period, is within a while one. While one means it's a infinite loop. Okay, it's a always true loop, so it will continuously implement this. So my LED will switch on, switch off, switch on and switch off, and that will continue for infinite duration of time. Okay, very easy, fairly easy program. There's nothing, I have not written anything, I've just changed a couple of values. The program is a default program, and anytime I click on new and I start a program, I will have the same bunch of instructions in front of me. What I will do is I will first save this. Okay, once the saving is done, I will compile this. Compilation is the process of converting this into a machine or a bin file, basically what my machine can understand. Okay, now I am connecting my Mbed board. Okay, now here at the bottom you can see that it is showing that some hardware has been connected. Correct? Okay, since it was a new device connected, antivirus is also giving a warning. All these things done. Now this is the file that got downloaded. Correct? This is the bin file that got downloaded. Let me see. Okay, what I do is, how I actually run this project is, this is the file that got downloaded. I cut this file, and do you see this KL25Z, which is the USB connection that I put in, has also come in. I double click, I select this, and I simply paste it here, Control V. That is what I do. Okay, I'm simply pasting it here. That's it. Okay, now just to show you the output, I will stop my screen share. Now can you look at the screen and see the output? The LED is switching on and switching off in every half a second. The wait period in Arduino and other controllers is in milliseconds. So if I write 0.5, it will be for 0.5 milli. If I have to do half a second, I have to write 500. But here it is in seconds. So half a second switched on, half a second switched off, and it is the red LED. I don't know if red color is clearly visible or not, but it is red. Okay. Now this is basically how we do it. Okay, we write one set of program or one set of code, set of instructions, save it, compile it. The compiled file gets downloaded, and once I have it downloaded, using my Mbed kit, when I connect the kit to my system, I have it in my computer section. I'll have a folder of that KL25Z. I just copy my file. I just move my file in the particular folder of KL25Z. The system automatically compiles and runs the program. Okay. Between the two USB options that we have, there is a reset button. Okay. Once I press this button, only the yellow color LED, which is the power LED, is on. The process has stopped. But if I release the button, it again starts. Okay, so this is the reset button. So it basically refreshes the code which is there. It doesn't delete anything, it just refreshes it. Okay, now this was a very basic program that we did. We will do one more today. I'll give you some more information about the board, and then we will call it the day. Let me switch this off. Okay. Yes. Now on the compiler side, let us do, okay, we will not do any fancy stuff right now. Let's try and work with multiple LEDs. So I said there are more than one LEDs here. So what I do, we will just call the other LEDs as well. Now, they will all be of the type digital out, but they need to have different names. So let me just give them 1, 2, and 3 as 3 names. LED 1 is red, LED 2 I think is blue, LED 3, sorry, 2 is green and 3 is blue. Okay. So I have called all the 3 LEDs now. I will just repeat the entire process and we will try to switch on one LED at a time and see if we are able to do that. Okay, now is this a correct program? Just write yes or no in the call in the chat section. What I've done here is I switch on the first LED, which is red, and then switch it off. I switch on the second LED, which is green, and then switch it off. I switch on the blue LED and then switch it off. And then will my if I compile this, will my project work or no? Can you all go in the chat section and just write yes or no? Will it work or not? Just write work yes or will it not work? Very quickly. I'll have the project again in front of you. Okay, the code in front of you. Very simple, right? जो हमने पहले एक LED के साथ किया था, I've just repeated that option 2 times extra for the other 2 LEDs. Okay, we are doing it for LED 1, we are doing it for LED 2, we are doing it for LED 3. Now, will it work or not? Yes, chat. I'm waiting for some answers. Will this work? Because logically, there is nothing wrong here. Logically, we have just copied the code 2 extra times, or we have written it 3 times, 1 time for each of the LEDs. Will it work or not? Rajesh says yes. Govind says yes. Arre, there are 30 people. Yaar, aur log answer karo. Please don't sleep. Also, please listen to what I'm saying. Okay, you all know a very famous meme that has been, getting circulated these days, where if you put your class in one corner and get involved in other activities, it could be disastrous. So yes, so 2 of you say yes, 2 say no. What about the other 30 odd people? You should have some opinions, right? Whether this will work or will this not work. Others? No. A lot of you are saying no, it will not work. Can any one of you unmute and tell me? So Yash Jadhav, Ketan Jadhav, Apurva, 3 of you are saying that it will not work. May I know why it will not work? What problem do you see with the code? There are no. Okay. Let's be here. Okay. Let's be here. Let's compile this code. Let's first save it. Save ho gaya. Okay, you get to see success here. No errors. I compile the code. ठीक है, नया file आ गया. My code got compiled here. Now tell me, will it work or not? So there are no syntax based errors here. Will the code work or not? Yes. Will it work? Will it give me the desired result? My expected output is 1 by 1, each of the colors should switch on and switch off. Correct?
So it won't work.
Why?
So we have to give the input, means we have to program like this, that if when the red color gets off, then the green color should work.
Got it. Correct. Who was it? Apurva, right? Okay. So let's try and see what output we get for this. Okay. Let's try and see what output we get. Okay, this is the file that got downloaded. I cut it, paste it here. Okay, now I'll switch off the screen share to just show you the output. Okay, now look at this. I have pressed the refresh button, so no color LED. Now when I switch it on, or sorry, when I release it, this is what I get. I get all colors except red, blue and green. I get all intermediate colors. I get white in between. ठीक है, पूरा रंगोली बन गया यहाँ पे. But जो desired output था वो नहीं आया. Yes. So how do we correct this? How do we correct this? Yes. So taking note of what Apurva said, when we are switching on one LED, we need to make sure that the other LEDs are off. Correct? So when we are working with this particular section, I will just try it. I will just make sure that the other two LEDs are off. So my LED 2 is off. My LED 3 is also off. Correct? And this is what I need to do for the other two times as well. 1 and 3 at one place, 2 and 1 and 2 and 3 at the other place. Let's do that. यहाँ पे कौन सा ऑन हुआ है? 2 ऑन हुआ है. I save this and I compile this. ठीक है? It success आ गया. That means no errors detected. It got compiled and got downloaded. Okay. Now will it work or not? ठीक है? Logic says it should work now. Okay. I go to this. I copy and I paste it here. It has become removable disk because of my antivirus. वरना KL25ZE आएगा. And then I move and replace. ठीक है? Now let's see what output you get. I will stop sharing. Yes. Okay. The code got compiled. Let's see what we have here. When I release the button now, I still have intermediate colors. I don't have red, green, and blue separately. Yes. Now look at this code, because the problem that we had, that when one color was on, the other two were getting on as well at the same time simultaneously. We had this problem. Now tell me what could be the issue. Now as engineers, most of you or all of you are expected to debug this problem. The program that we have written is logically correct. Okay, I will just take you through the program once again. Okay, now understand the program well. Okay, Mbed H is the header, is the general header file that we use. Okay. What we are doing is we have declared 3 LEDs. The first one is your red LED. This is your red LED. The second one is your green LED. The third one is your blue LED. Okay, we have declared. So digital out is the variable type. My LED 1, 2, and 3. My LED 1, my LED 2, my LED 3 are the name of the variable, and these are where they are connected. LED 1 is red, green, and blue. What we are doing here is int main while 1, that means continuous process. LED 2 and 3 are off. LED 1 को on किया and then LED 1 को off कर दिया. Then, and all these operations are separated by some wait period. Then LED 1 and 3 को off किया, 2 को on करके 2 को off, and then 1 and 2 are switched off, 3 is on and then 3 is switched off, and I close. I did this, but the project is still not working. Can anyone debug this? Anyone who does give me a correct answer for this, I will personally give them a separate letter of appreciation. Yes, anyone? Anyone who can give me an answer? I'm looking at the chat section. All of you are looking at the chat section. Yes, tell me. What is the issue here? Time delay? Okay, no, time delay should not be an issue, because we have given, if you want, I can show you the, I can increase that delays in between as well. But 0.5 second is a good enough delay. Okay. So, no. Anything else? Ketan, good thought, time delay, but no, that is not the right way. Anything else that you can think of?
So, if we are using 3 LEDs,
yes,
then other LEDs should be off.
So there are only 3 LEDs there. There are no more than 3 LEDs. So जो combination of colors दिख रहा है ना, that is because simultaneously more than 1 LEDs are switched on. जो हमने software में हमने ध्यान दिया था उसका, by switching off the other 2 LEDs. That is what we have done here, right? If you look at the program, when we are working with LED 1 switching on and switching off, we are making sure that the other 2 LEDs are off. That is why we added these 2 lines. But even now it is not working. Okay, now that we are approaching time, I'll quickly tell you, there is something called active low connections. Okay, I will just write it here. This is what I expect you to read and come tomorrow. Okay. What are active low connections? Yeah, I want you all to read this and come tomorrow. What do we actually mean by active low connections? Okay, active low, and why do we have this? What are and why do we need them? I want you to read and come tomorrow. This is the first thing I'm going to ask tomorrow at 3, and then we will continue. What are active low connections? Now, active low means when I write a logic 0 here, it is actually treated as logic 1, which means if I have to switch off a particular LED, I will write 1 here, exactly reverse. Okay. So every time I write any LED equal to 1, it is treated, it goes to a NOT gate and it is treated as 0. So जब मैंने 0 दिया तब वो 1 होता है, जब 1 दिया तो 0. Okay, so I'll give comments also. I'll share the codes also with you. LED 2, I'm not doing it again and again, so this switches off LED 1. This makes sure that LED 1 is also switched off, so all 3 are switched off here. Now, Have I done this for all three? Yes. I save this and compile. Yeah. Control X. Okay, my laptop is really slow now. Okay. And now I will just stop screen share to show you what the output we get after we make these small adjustments. Yes, so I press the refresh button, okay, and then when I release it, you have red color, you have green, and you have blue. Three colors, one after the other. Yes, visible now?
Yes, sir.
Awesome. So, three very quick points, okay? Why did we do this project? Is this a project? No, it's not. This is just to test whether your board is interfacing well with your laptop or not, whether you are able to write, whether you are able to go to the compiler, compile and download a file. Are you able to put this here? If yes, are you able to check the output on? Okay, this is what this activity was all about. The second thing was understanding that what are active low connections. I'm not going to talk about that. I want you to read second years and third year students. I want you to read what active low connections are and come tomorrow. We will have a small discussions on your answers, and then we will take it from there. The third thing is the Mbed compiler. So I will very quickly. Okay, at the very end, I will share the presentation with you, with all of you. I'll share it with ma'am, and then she can forward it to you all. The idea is, at least you all don't have the hardware with you, right? You all don't have the hardware to do projects simultaneously with me. But I want you to go to Mbed compiler. Okay, I want you to go to Mbed, EMBED. Sorry, MBED, not E. Mbed.com. Go there, sign up. Okay. After signing up, go to the compiler option, select FRDM board, KL25Z board. Once you have that board selected, try and write. You will have the same default code popping up in front of you. Make small adjustments, play around with the LEDs. You have three LEDs. Those three LEDs can give you any color in between. Between white and black, you can have all the colors. Okay. There is a project called fading in of LEDs. Fading in means जैसे ये कलर एक आ रहा है जा रहा है आ रहा है जा रहा है. So this is a digital switching on and switching off type of things. Can you, using the concept of PWM, pulse width modulation, can you slowly breathe out the LEDs and then breathe in? That means अचानक से off नहीं होना चाहिए. धीरे-धीरे intensity कम होके off हो and then धीरे-धीरे intensity बढ़ के on हो जाए. ठीक है? These are some of the things that can you do it. This is what is done in the lightings that you get for decorations at your place. चाहे गणपति हो दिवाली में हम लगाते हैं ना अपने घर में. This is how they are coded. Okay, this may sound or may look a very silly project, but it has real life application. Okay, just by using an RGB LED, which is red, green, and blue, all three colors, you can get any shade in between and you can create any design. You can switch them on and off in any manner as you want to get a particular design pattern in front of you. Okay, this is what I wanted to demonstrate today, because just to give you a feel of how to make a project and put it in the system. Tomorrow we will start working with the output devices first. We will, if time permits, we will also look at sensors. If you all have any queries, okay, if you all have any questions regarding anything that we discussed today, you can just note it down. Okay, you can keep it noted with you. tomorrow when we begin at 3, we will have a small 5-minute Q&A session at the beginning, and then we will go ahead and we will look at some new concepts. Okay.
Great.
Thank you so much, everyone. Thank you so much for your time.
Thank you.
I know this is slightly new and it might look really ugly looking at these things online, but the idea is to just just to give you a feel of how this system works, and hopefully if the pandemic gets over, we can actually do a workshop within your college, with having you all with you and handing these boards to you, and we can see if we can do things like this. Okay, thank you so much, everyone.
Thank you, Mr. Gaurav. It was a pleasure listening to you. I'm sure my students are getting benefited, even though they're sitting at home. Thank you for all the efforts that you have been taking, and it's really always good to see you organize. You're so enthusiastic all the time. I myself love attending your workshops. Thank you, Gaurav, for being so nice and patient with the kids. I know students, the guidelines that has been shared by you, I'm sure most of you would adhere to it and would like to experiment with what has been done today. Of course, you don't have the boards with you, so you'll not be able to see. I don't know how to, maybe you can purchase online. Gauravji would help you in getting those websites from where you can get the authentic boards, and then you can at least once you know the protocol, you know the process, you can actually work on and complete it. Okay. Thank you, Gauravji. Let's again meet at 3 o'clock tomorrow. Thank you, all the participants. Kindly ensure all your friends join well in time. We only have 50% strength today. I do not want to see this kind of a strength because we are taking attendance on daily basis, and only those who attend all the 3 will be getting the certificates. We'll not meddle with that. Thank you. Thank you all for joining. Thanks.
Thank you.